All right, I think we'll go ahead and get started. Sorry for the delay. So, I'm Mark Matthews with Oracle, and this is Todd Farmer with Oracle.
Yep.
And we're here to talk about reliability and scalability features that are built into Connector J. I work on the MySQL Enterprise Tools team. You probably saw me demo something this morning. And I'm the original author and part-time maintainer of Connector J. And Todd works in the support team, and he also helps maintain Connector J. He's done a lot of work around some of the load balancing stuff that you'll see here in a second. So there's a couple of different variants of load balancing built into the JDBC driver. There's one that is pretty much a straight-up load balancer. The URL prefix looks like JDBC MySQL load balance and a list of hosts, and it basically assumes that you can send a transaction to any host. So the use case there is MySQL cluster NDB, and those are SQL nodes, or that you have master-master replication, or that it's a bunch of slaves and they're up to date enough that they can all be treated roughly the same. There are also some indirect methods of load balancing in the JDBC driver. There's this thing called the replication connection, where the first host is the master, and as long as the connection is not in read-only mode, so connection.set read-only false, then queries will go to the master. You set the connection to read-only true, and it will go to whatever the second and further nodes in that list are. There's also a failover variant, which and it actually goes way back, and we'll have a short history lesson here in a second, but it's where basically all your queries should go to one server unless it fails, and then they should go to another one. And you can either fail over read-only, so that when you're in a degraded mode that you only allow reads to happen, so for example if you have a slave that you want to go to, or you can fail over read-write, which is a little bit more dangerous unless you have some fancy recovery mechanism for the secondary node. So a history lesson, the last thing I talked about was the first thing implemented. It's been in the JDBC driver since 2002. Starting with the next release of Connector J 5.1, that behavior has been replaced by the load balance connection, which you'll hear a lot more about in a second, under the hood. So actually the failing over and then the balancing among slaves is all handled by the same kind of logic that the load balance connection uses. The replication connection thing has been around since 2005. In Connector J 5.1.11, we replaced the series of slaves with the load balancing connection under the hood. You can sense a theme going on here? But basically, it's kind of all the same thing under the hood, it's just slightly different behaviors. And then the JDBC MySQL load balance, where it balances across a heterogeneous pool, has been around since 2007. That went in Connector J 5.05. And really the impetus for that was when MySQL acquired NDB from Ericsson, and they needed a way to route requests to any number of simple nodes. So the thing to consider about load balancing, if you're going to do load balancing or any kind of semi-automated fault tolerance, is that there's no magic bullet. You'll hear vendors talk about, well, you just plug this in and it just works and it's all great. But really, to pull this off, you really need to understand your application, and that's pretty easy. Not easy, but your developer should understand it if it's something you build. I think they'll know these metrics we're going to talk about. But the trickier part is you need to know the production environment a little bit. And I'll get into that. So what you need to understand about your application is how transparent should failure be to your end users? What kind of expectations are you setting up? Do you never want an end user to see an error message or service unavailable of any kind? Or is it okay for a few percentage of your users to get a try again? Is it okay for some user requests to hang while failover happens? So it may be a while until the next available resource is picked and then their transaction proceeds as normally. You kind of need to know those things because it drives how you approach failover. It also approaches some things you'll plug into load balancing. The trickier thing to understand is how transparent can failure be to your code base. What will your code do if it sends queries to one place and then in a subsequent transaction, it's actually a different server, right? So if you have written your code in such a way that there are things that persist between transactions like temporary tables or session variables or things like that, then you're going to have to do some work to make load balancing and fault tolerance work because the JDBC driver is not aware of that stuff. Luckily, if you're using a persistence framework or something like Spring, most of the time they don't they kind of move you in a way where you don't end up doing those kind of things, so you're safer. The trickier part with your application is knowing when it's okay to retry a transaction, because if you're doing load balancing or fault tolerance, the key concept is that if a certain class of failures are detected, to the first point of how transparency failure be to your end users is it okay to retry the transaction? And what constitutes the unit of work that's safe to retry, and how do you retry it? It can be as simple if it's a hand-rolled JDBC that you catch certain kinds of exceptions that will happen when you experience the kind of failures that mean a node is down, and those are communications failures. SQL state 08 starts with 08. If you're using JDBC4, there's actually a special class of exceptions, transient exceptions, which means that you can SQL transient exceptions, which means you can retry. But then it's how do you wrap that logic around what you're doing? How do you get your application to back up the call stack and restart the transaction? And this is where if you either put your app together, like a lot of the modern frameworks use, where data access is templated and the actual concept of getting a connection, starting a transaction, and then doing the work is actually often a template somewhere or some localized code, and then the actual transaction work is some anonymous class or something you pass in. So for example, a model of that would be Spring's JDBC templates or Spring's Hibernate templates. Or do you have set auto commit and do all this stuff sprinkled throughout your code base? I would say if you're in that situation, first clean up your house and get that stuff all centralized and reusable, and then it will be a lot easier to do things like failover and load balancing because you'll just write the implementation of it once. And the reason you need to do this is because there's really, like I talked about before, about all the things you can do to have state go beyond transactions, or even know if it's just appropriate to retry a transaction. Like if you get certain kind of failures, maybe you do want to send an error message to your users, and other times you want to retry. So the JDBC driver makes no attempt to make failure transparent. If something happens that causes an exception to be raised, the way that all of the failover policies in the JDBC driver work is that you will get an exception. The failover, the load balancing, etc. happens on the next start of a transaction. So as long as you're still in that transaction, you haven't handled the exception, haven't gotten, rolled back the statement or anything, you'll continue to get exceptions every time you try and touch something. What it can do is help make recovery transparent. And that, after you deal with the exception, the next time you try it, if you're using any of the load balancing stuff, it will go figure out what host it can connect to and replay your transaction. The next thing, this is a little bit harder, is that you need to understand your production environment. And this is where this is the key part of making sure that these kind of failures and faults are transparent to your end users. And the reason why is because knowing your production environment, knowing how your network behaves, knowing how it's set up, knowing about how long things take generally, drives many of the configuration values you'll plug into Connector J, into MySQL, into your operating system, etc. The more you know, the better, and it's not a one-time deal. You deploy new versions of your app, you put new hardware in, things get flakier over time, cabling wears out, those kind of things. So it's the kind of thing you have to, this is like a plug for Enterprise Monitor, it's not. It's the kind of thing you have to monitor over time. One thing to know is that a lot of people like DNS because it's kind of a secondary level of indirection. Like if I want to repurpose a host, I'll just keep it in DNS. If I need to change it and I have short TTLs, I'll just put a different value in there. You need to know that if you do that, one, that DNS has now become a linchpin of your production environment. And a lot of DNS servers aren't the most stable things in the world. And there's stuff all up and down the stack that caches those values. There's caches that run in the operating system. There's caches that are in the C library. There's caches in Java. So you need to know where all those things are if you're going to depend on DNS as part of your load balancing or fault tolerance strategy. I would recommend not running it unless you have somebody that really knows DNS well and knows where all the dusty corners in your infrastructure are. But then it's a pain because everything is dotted quads. But you can somewhat automate that. So for purposes of our talk here today, I think there's two key data points. One is to know how long does it take to set up a connection in your environment, right? So, and a TCP connection. So this is an example. I just wrote a simple benchmark, ran it in one of our environments, and picked the 95th percentile connection time. One thing to notice here when I say cached and not cached, this is the cache server configuration values, variables equals true, parameter for connector J, just to show that there is a difference in how quickly they connect. So it's about twice as fast to connect when you're not always retrieving those values. But the 95th percentile case is important, and I'll get to that in a second. Now, how many of you had to take stats in college? I'm sorry. Statistics does come into play because really the numbers you're looking for when you're designing failover and fault tolerance are percentiles. But often that's not a useful number to be able to collect because if you have high volumes of things, to get a percentile, you have to have the entire population, then you rank it, then you look at it. And when you're talking about like all the queries in your application over a long period of time, that's hard to come up with a percentile because that's a lot of information. But you can cheat. If you took statistics and you know about standard deviation, you know averages, then you know if we're assuming a normal distribution or relatively normal, so you know if you have a way to get the average time and the standard deviation, both of which can be computed as running totals. You don't need to have the entire population. You take the average, and there are a bunch of smarter mathematicians than me that say that 90th to 95th percentile is going to be 3 standard deviations away from the average on most data sets. So if you want the 95th percentile query time, which I'm going to talk about, if you know the average, you know standard deviation, you can derive it. The one that's important is to look in your app and find the worst average case query, and also know the worst query ever usually in your app. And these are numbers you plug in because you want the worst average case. You use this in the standard deviation to determine a number, and if it's higher than the worst case query you have, then you can use that. Right? So where you use these numbers is Java, the operating system, even connector J. There's some timeouts. Timeouts are useful. They tell you when something has failed. And we use the defaults because there really are no same defaults. The problem is that the defaults are often in minutes. So for example, there are certain failures in TCP/IP that may take up to 10 to 15 minutes for your application to notice that the connection is gone or can't be established. That's not real great in a production environment. Is there a better number? Yes. What is the better number? Depends on your environment. So that's why you need to know these numbers. So I would, back of napkin math, if you're going to configure for fault tolerance or failover, I would, figure out what it takes 95th percentile to connect. Or, you can pick a number, but you could write a simple benchmark. Just open up JDBC connections against your production servers and then close them and time how long it takes over various parts of the day, right? And different loads in your environment. Be like a civil engineer who says, I'll take that number, but I'm building an elevator, people might die if it breaks, and I'll come up with a safety factor, 2, 3. Chances are that will be a number that is much less than 15 minutes, and that's the number you want to use. Okay? So that configures how long it will take before Java itself will notice that it can't connect, it can't establish TCP/IP. This is important both for the load balancing and for fault tolerance. There's a socket timeout, which is basically use the average or the mean worst query time plus 3 times standard deviation, so that you're getting the worst or the 95th percentile of your worst query, put some safety factor in there. And the reason you do that is because the way MySQL works is that if it's processing a query, the timeout starts when I send something to the server, and then the network stack is going to wait until something's sent back. And MySQL doesn't send anything back until the query starts coming back. So you don't want to set that so low that you're getting exceptions before your results are getting returned. So that's why you'll set that to that. And for the safety value, what are you comfortable with? If you really care about fast failover and fast switching of hosting or load balancing, you'll dial that down a bit. If you really think that your numbers, when you graph them, however you graph them, look all over the map, then maybe you'll bump that up a bit because it's just a noisy system. But just about anything is better than the defaults, but I can't tell you what that number is because if I give you something, it might break your app. if you're using a modern version of the connector, and in any of them they have the load balancing connection under the hood, probably the most important parameter you can set is this load balance blacklist timeout. It's a long parameter. Basically what it means is the load balancing connection keeps a list of hosts that it knows have failed, right? And if it's doing load balancing or failing over, it won't connect to those hosts until a certain amount of time has passed. And then after that time has passed, it will try to connect, it will put that back into rotation to use again. The default currently is 0, which means that we don't maintain the blacklist of failed hosts. It just retries and retries and retries. So Todd talk about some additional things he's been working on that are coming soon.
I want to see if we can get on mic.
Yeah.
Yeah, it doesn't look like it. Okay. Well, we'll use Mark's computer then.
Fault tolerance.
That's right. So Mark got to talk about some of the math stuff, but we've got some fun new functionality that's coming that will support load balance deployments starting in 5.1.13. One of the things that we've seen is that that people sometimes need more fine control over when the load balancing connections will fail over to another host. Right now, we have a pretty standard exception handling process. So load balancing connections will fail over or may choose another host from the load balance pool under 3 conditions, basically. Commit, rollback, so we know that the transaction has been done and it's safe to fail over or choose another host, or we get an exception, and specifically communication exceptions, which tell us that the host is unavailable. So these items that we list under the standard component right now are pretty much the triggers for us to choose another host caused by a SQL exception. So communication exceptions, any SQL exceptions that have a SQL statement that starts with 08, which Mark mentioned. We've added to that in 5.1.13 the ability to set SQL state that you specifically want to fail over as a result of, as well as user-defined class lists. If the class or interface that you've defined matches the SQL exception that we see, we can trigger that. There's also a new hook that allows you to extend that and write your own load balance exception checker, which is the name of the interface. So it would allow you to take a SQL exception, inspect it, determine whether or not you want it to trigger a failover to another host or not, and then return that whether or not it should. So in some more detail, just really quickly, the standard load balance exception checker, there's a comma delimited list of SQL state values, so you could put in whatever SQL state it is that you want to cause, that you want to have as a trigger for a failover. We also match, it's a trailing wildcard, so if you give us 08 in that list, it'll match anything that starts with 08. This is the new property, load balance SQL state failover. Second new property is load balance SQL exception subclass failover, and this is a comma delimited list of fully qualified class or interface names that we will compare the SQL exception against to determine if it matches that, and if so, we'll use that to trigger a failover. This, yeah, good luck.
Hey Gary, what's the hotkey for magnify?
Hold control and do the 2 finger just want to make it big.
Oh.
Man, I broke your computer too.
Go ahead. So I'm going to zoom in. Okay, so I can't zoom in. So we'll just explain it. Yeah.
Okay, so this is an example of a custom exception checker, and specifically we're writing this to handle some exceptions that are thrown by NDB cluster, the storage engine. There are some very vague errors in MySQL cluster which basically indicate that the cluster is unstable, and you probably don't want to remain connected to that node that generated these errors. So what we've done is we've actually, in this example, we've extended the standard load balance exception checker. We've added another method that says we're going to inspect the SQL exception message and find out if it's, for example, lock wait timeout exceeded or got temporary error from NDB. If it has these magic strings in it, we're going to say, yeah, that's something we want to fail over to another host for. So that's an example of where you might use this type of interface, roll your own and say, I've got this, I'm getting this exception back from my MySQL instance, and I don't want to stay attached to this MySQL instance any longer. I think it would be best for me to fail over. This also triggers this particular host to be added to that global blacklist that Mark talked about a little bit earlier. So you run into this exception, we see it's an NDB temporary error from NDB, we add it to the global blacklist, you've got that set to 2 minutes, it's not going to retry that host for another 2 minutes. This is kind of where it gets a little bit exciting for me. We're adding some management capabilities to load balance deployments. Specifically, we'll be able to monitor statistics. So you'll be able to see how many active or configured hosts you have, active total logical connections, which are different than active and total physical connection counts. The load balancing implementation is such that your application gets a logical connection object, but underneath that it may retain a physical connection to each host that you've specified. And so when you go and you switch hosts, it will essentially be a connection pool. It's keeping those physical connections alive, and pick a new host, find that if it has an existing physical connection, it will reuse that, and if not, create one for it. So ideally, you will have a logical connection that you'll keep using, and it will be able to reuse the existing physical connections. So you'll be able to get metrics around that. You'll be able to get metrics around total transaction count. But one of the things that's kind of new and falls into the DNS issue, a lot of times DNS is used in these types of deployments because you want to be able to swap out boxes, and it's an abstraction, so you can say, okay, this actual physical host is now this host name. You can actually now, with 5.1.13, you can actually add new hosts and remove hosts from live running load balance connections. So you would be able to specify them using IP addresses and easily and gracefully remove them and change over and fail over to another host. We're introducing an abstract called connection group, which basically is a logical name group of connections that's within a single class loader. So, for example, you may have an application that has direct connections to the database for online transaction processing, but you may also use a message queue or a Java message service, and that has its own separate connection to a database. You may want to manage those independently, and so what we have is you can define those with a new load balance connection group property. So you can say, this is my JMS connections, this is my application connections, and you can manage those independently. In order to manage these live and be able to add new hosts, you have to define this value. If you don't, you won't be able to manage them in a live environment. The other thing is the connection group span connection allocation, or creation and allocation. So if you have multiple places, you have 5 different data sources, for example, you can, within your application, if you say that all of them have the same load balance connection group name, they'll all be managed as one logical connection group. Connection group, you can obtain this via the connection group manager class, which is new, and basically a static method get connection group, and you pass in the string name, and that name would match the load balance connection group property that you set in the URL. And then there are also comparable static methods within connection group manager that can be used, and you pass in the group name to start with to specify which of the connection groups you're wanting to affect. Statistics, there's some methods here in terms of the information that we talked about earlier. Manipulation, add host, and again you would specify that as, for example, localhost :3306. And you can add it to existing connections, so it will go in, and if you have logical connections, it will actually inject that host into the possible hosts that those existing connections can use. And then remove host will gracefully remove that host from use. We have a live demonstration right over there on that computer. It's really awesome. Unfortunately, we're unable to get it onto something that you can see.
One more time, or two.
Okay, well, we'll try and put the code online and find a way for you to get that. But we've also added a JMX manager for this, so you can enable this. I did not put it on here because I actually added a property that you have to set to enable JMX. But once you've got that enabled and you've enabled remote JMX management and you've got Java 1.5 running, you can actually run JConsole or whatever you prefer and go in and actually add hosts, remove hosts, and you can watch that all happen. You can see which hosts it's connecting to. You can get transaction counts, connection counts, all of those things that we talked about earlier, and it all happens without any sort of exceptions. One of the things that we've also added are some logic checks to make sure that when you're removing a host, you're not removing the last host from the list of hosts, so you're basically taking your entire application down. So there's some things that we would have demoed here. I'm sorry that we're unable to do that.
I'd say come to the BOF tonight if you want to see it. We can, walk to the environment and come and actually see it and play with it.
Yep. All right.
So I think one thing we neglected to tell you that's kind of nice is that the load balancing algorithm is actually extensible. So you can plug your own in. We ship with some. There's one that's based on best response time. There's another that's based on a random distribution. There's another one that's a sequential round robin. But it's a pluggable thing. You can put your own in and you can make up whatever policy you want. I have an example of a way that you could build horizontal partitioning that's pretty transparent to the app that sits above it. And you don't have to do, it's just a little bit of code that you plug in and you don't have to, fork our driver or anything. The way you install a load balancing algorithm is with the load balance strategy and then a fully qualified class name. And then what you do is there's a method you override called pick new connection that passes you, the list of hosts that have been configured in the URL. You can get the blacklist if you're going to use the blacklist. You can get the map of active connections for given hosts, and you can go wild. Whatever kind of policy you want to come up with, you could. And then a little demo of, if you have horizontally partitioned your app, every once in a while somebody will come to you and say, we've got this feature, it's really great, it's killer, but it has to go across all the partitions and all the nodes. And you're like, that's a pain, because how do I do all that? And if I'm using Hibernate or some other stuff plunked on top, it doesn't know about that. And what can I do? So a quick example of how you might pull something like that off with another feature called statement interception. So I'll switch to so the example basically, it's a really simple example. It's not meant to actually be a real implementation. It's just meant to spark some ideas. So thank you, Jan, for this approach. I think this is a good approach. Basically, this is just a list of this URL here as a, JDBC MySQL load balancer. I already talked about that. I have a list of servers that happen to be running on my laptop. And here's the database, and this gets fed in. This list of hosts gets fed into the statement interceptor. I'd like a cleaner way to do that, but right now we don't have it. Setup URL, I don't necessarily go in that. It basically just looks at this, figures out that there's 4 databases, creates a table on all the different nodes, and populates them with different data. So, node 1 has like the value A in it, node 2 has the value B, node 3 has the value C, etc., etc. The way that the statement interceptor works is that you actually list out queries of this form, actually should be run across all partitions and joined into one giant result set and returned. And the statement interceptor that does this is parallel query statement interceptor, which is here. There's not a lot to it. There's the set of parallelizable queries, so we can match on it. There's a executor service. If you're not using Java util concurrent and all the fun stuff that's in there, you should really take a look at it. There's a lot of nice stuff. And you'll see how this works in a second, but that's basically just a thread pool that's going to do the parallel query. And there's a list of connections to all the nodes. So the interesting part, this is all just set up, that's not really a big deal. But the way statement interceptor works are there are basically 2 hook methods that are important. There's pre-process and post-process. And basically those are 2 points in the life cycle of processing a connection. One will get called by the driver before it sends a query to the server, and you're allowed to return a result set. And if your statement interceptor returns a result set, then that's the one that the driver uses and not the one that came from the server. It skips sending the query to the server altogether. And there's post-process, which basically hands you the result set and the statement that came from the server, and then you can munge it and do whatever you want with it and then send it up. And what we do is basically, if it looks like that query is one we know about, then we just make a list of futures, which are basically just a way to, in a threaded environment, know when an asynchronous job is completed and move on. And we just fire those off to the thread pool, and we take all the parameters in the prepared statement if they're there, and we set them on another prepared, that same, or a copy of that prepared statement that we're sending to every server. And then we have this pipeline result set. I won't go deep into it, but it is just a basically a proxy interface, Java lang reflect proxy around result set that basically just lets us chain all these results that we're about to get from the server back into one, so that it's transparent to that. Now, exercise left to the reader. If there was an order by in there or something like that, you'd have to do something a little bit more complex, but it's not an impossible thing to do. We have nice things like tree set and stuff at your disposal, so if you want to navigate the result set and sort it yourself client side, that would be possible to do. And then I'll go really quickly, because we're getting a little bit short on time, we just overload the load balancer to pick a new connection based on a thread local ID. There's nothing real magical there, and the source code is actually up in the source code repository, so you can look at it. So let's just run this and see what happens. Poor man's doing what's going to build. So poor man's debugger, I just have system in print lines at the key points, because my workspace is full of other breakpoints that probably won't be interesting to you. While we wait for this, any questions so far? Yes?
So with this thing, what's the impact to the connection pool? If you try to use the connection on top of this, what's the impact?
So this seems to, so the question is, you know, what is the impact to a connection pool? How does this interact with the connection pool if you're using load balance connections? In general, it's pretty transparent to the connection pool. We have people that are using this from within connection pools. Probably the trick is to make sure that that your application is configured to, even if it's read-only type stuff, that it brackets everything with transactions. Otherwise, our stuff gets very confused about when it can fail over in load balance. But other than that, people are using it with it. We know people use it with Glassfish, DBCP, JBoss. So it's in use in production in connection pools. The only thing you have to remember is that there's kind of a multiplier, because you have the pooled connections, the logical pooled connections, your app server are then, expanding into possibly, end connections to various different backends. That's the only thing you have to keep on top of.
But in your case, the connection to the load balance will remember the thread local ID. So in that case, there will be many.
What's the question?
So if the load balance remembers the thread local ID from the application for that connection, and then load balancer side will remember a lot, and in that case, so how the connection sharing between?
The load balance connections are private to a logical connection, which is then one connection in your connection pool. So every one connection in your connection pool may be backed up by a bunch of connections. Only one in use at any one time, and those aren't shared amongst other connections. So if you were to draw a line from your app through, it's always through stuff it owns. It's never shared from the point where your app uses the connection on the connection pool all the way to the back end. Those connections are never shared with anybody else. Does that answer your question?
I think so.
Okay. Well, think about it, and then you can catch us in the hall. Yeah.
So how would it distribute, you had a connection pool of 100 connections, and you had 2 servers for load balancing. How many would it create? 50 and 50, or?
Each logical connection, so in that case you've got 100 logical connections, could be backed up by 2 physical connections, one to each host. So you could end up with 100 on each host or 200 total physical connections.
Okay. And if they failed over, would it fail over the whole pool at once?
When it detects. So it's not, we don't shift everything. It's not a proactive failover in that when it detects a failure, it's not going to say, oh, everybody else stop using this. If you're on this host, it's when it comes time to pick a new connection that it will move over. And we don't have a load shedding thing built in where you'd say, only fail over half, or slowly fail over and let other stuff, get exceptions until, it recovers. Yes?
I just want to make sure I understand your scenario here. Is this a failover scenario? Or are you trying to use multiple backends and horizontally partition it across multiple backend data simultaneously?
So the load balancer itself, depending on how you use it, but you can use it to distribute load across a bunch of servers as long as they're heterogeneous, they have the same stuff on them, or it's plugged in as the guts of other things, the JDBC, MySQL, with just a list of hosts that is fault tolerance, or the replication that is fault tolerance, or a little bit of scalability. So it's the same stuff under the hood, but it's used slightly different by the driver.
Yeah, but for this demo,
for this demo, it's horizontal partitioning, and we have different data on each node. So here, really quick, I'm going to get the wave off here in just a second. Okay. All right. So come to the BOF. We'll finish the demo. We're getting the wave off. So sorry for the late start, folks. That's an excuse to come visit us later tonight at 8 o'clock. I don't remember what ballroom it is, but there's a list of the BOFs out here in the hallway. So we have the late BOF. Thank you.